Solving equations, 3-1. Chapter 3 starts in solving equations, and they start with the really simple ones, and they get really hard quick. So, if you are a student who had me last year for math, you know how picky I can be about solving equations. So that's the bad news. The good news is I'm going to be a little less picky this year in algebra. I'm going to allow you a little more leeway. You're going to like that. If you are a student who has not had a teacher who is picky about solving equations, then you might need to make sure you watch this video more than once, because obviously the answer to the first one is 3. We can all see that it's 3. But the process of how you find it comes into play as it gets harder. And if you don't learn your process, you're not going to be able to do the hard ones. Sure, anybody can do the easy ones without solving and checking and showing all work. But not many people can do the hard ones unless they learned how to do the easy ones correctly. So let me remind you of some things. First of all, when you're solving equations, your goal is to isolate the variable. What does that mean? Isolate the variable. It means get the variable on one side of the equation all by itself. So my goal is I want y to be all alone on one side of the equation. What is in the way of that? Well, plus 7. I need plus 7 to be gone. To get something gone that is added or subtracted, you do the opposite. So minus 7, minus 7. And then y equals 3. And that's the answer. Now, I made you check it when you were in pre-algebra. I'm going to allow you to check it mentally if you would prefer that, or you can check it normally, but you need to check and make sure you have the right answer. Of course, in this one, it's pretty simple. If you don't remember how to checking, you write the original equation, and then you stick 3 back in for y, and you work down and you go, well, 3 plus 7, that is 10. So that's how you would check. That's the way we learned last year to check. Now, if you can see that that's the right answer, you don't have to check. If you can check mentally. So there's your first little bit of leeway. Now, it's also good to know that there's actually more than one way to solve even the simple problems. There's a horizontal method and a vertical method. The method we used last year was the vertical method. Okay, we worked down. When we saw x minus 5 equals 3, we said, oh, we want to get x by itself. The opposite of minus 5 is plus 5. So we went plus 5, and we worked downward. So we ended up with x equals 8. Okay? The horizontal method is used by lots of teachers and lots of kids, and it's a perfectly good method. And the reason you sort of need to be exposed to it is, what if you get a teacher in a different class or a different school or even in college that does it the horizontal way, and you're like, what are they doing? Okay? It's really the same thing. In the horizontal way, you do the same thing. You go minus 5 plus 5, but you do it all up on this line. See the difference? But see how it's really the same? The vertical way comes down. The horizontal way, I just added in a cross. I still end up with x equals 8. Both of these are perfectly good ways, but this is the one that you are most familiar with if you went to school here last year. This is also the one I think that Okay, here's another problem. Negative 6 times x equals 48. Okay, I need x by itself. Remember, I want to isolate the variable. So how can I get rid of this negative 6? I can't add it or subtract it because these things are multiplying. So I have to do the opposite, which is divide by negative 6 and divide by negative 6. So that cancels out. You get x equals negative 8. That's the answer. That makes sense. Negative 6 times negative 8 is 48. I just checked. What about when the problem says 6 equals t minus 2? It's turned around backwards. You can work it backwards. It's perfectly fine. I need t by itself, so I'm going to say plus 2. Plus 2. That cancels out. That leaves t equals 8. And that's the answer. That makes sense. 8 minus 2 equals 6. Here's another problem. X over 4, or x divided by 4, equals 5. Well, since I'm dividing, the opposite of that is multiply. So I'm going to say times 4, times 4. Put that over 1, that cancels. X equals 20. That makes sense. 20 divided by 4 is 5. That's logical. Now, sometimes you have problems that say things like negative 2/7 x equals 4. Okay? You can multiply by 7 and get rid of the fraction. Take the whole thing, multiply everything by 7. That's going to cancel here. 7 and 7 cancel there. That leaves you negative 2x. And then 4 times 7 is 28. When you do that, you got to multiply this and this by 7. Now what? I need to divide by negative 2. Divide by negative 2. X equals negative 14. That makes sense, because negative 2 times negative 14 would be positive, right? Positive 28. 28 divided by 7 is 4, so that checks. Now there's one other way you could work this problem. You could take your negative 2/7, x equals 4, and you could use the reciprocal. Remember the reciprocal? That means you flip it. The reciprocal was also called multiplicative inverse. So that's negative 7 over 2 times negative 2/7 x, that's our original problem, and then 4 times negative 7 over 2. Cancel, 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 cancel. That leaves x. Well, 4 times negative 7 is negative 28. Negative 28 divided by 2 is negative 14. So x equals negative 14. Either way, I get the same answer. Multiply by 7, get rid of the fraction, or use the reciprocal in this case, since there's only one fraction. Okay, let's look at that one more time. You've got options. When you have one fraction, you have options. Okay, take this fraction and flip it. Do the reciprocal. 3 over 2 times 2 over 3p equals 14 times 3 over 2. See, here's my original problem. All I'm doing is multiplying both sides by the reciprocal of 2/3. That's a perfectly wonderful way to do it. This is going to cancel, that's going to cancel. You're going to end up with p equals 3 times 14 is 42. 42 divided by 2 is 21. There's your answer. If that way bothers you, then just put some big brackets around the whole thing and multiply everything inside the brackets by 3. If you multiply 3 times 2/3 p, the 3's are going to cancel and you're going to have 2p. If you multiply 3 times 14, you're going to get 42. Then divide by 2, p equals 21. Same answer, because there's only one answer to the problem. Two different methods, both are valid. They're easily checked. If you put 21 back in for p, you go 2 times 21, well that's 42. 42 divided by 3, well that's 14. It checks. Here's another problem that has more than one way to work it. Yes, you can have decimals in solving equations. So work it with the decimal. b minus 0.4, we need to get rid of 0.4 because we need b by itself. So we're going to go plus 0.4. And then you're going to go plus 0.4 over here, line up your decimals, and get 3.5. b equals 3.5. Pretty straightforward and easy, right? That makes sense. 3.5 minus 0.4 is 3.1. That's logical. It checks. If you want to learn the other way, there's another method to do it. The other method has to do with multiplying everything by 10. Now, why would I multiply everything by 10? Because if you multiply this by 10, the decimal moves over a space and makes a whole number 4. That by 10, it moves over a space and makes the whole number 31. And the decimal's gone. Some people don't like to work with the decimal, so they always do this method. But you got to make sure you do everything. It's kind of like the distributive property. Everything inside the brackets has to get the multiplying. So 10 times b is 10b. 10 times 0.4 is 4. 10 times 3.1 is 31. Now my decimal's gone. So my problem looks like this. Then I can go plus 4, plus 4, that's 35. 10b equals 35. Divide by 10, divide by 10. b equals 3.5. Same answer, a different method. You can use either one. Sometimes this method's easier. Sometimes this method's easier. Or sometimes someone just has a preference. They like one better than the other. Now, if you really love fractions and you love working with fractions, you can totally work this with the fraction. Because you could do minus 1/8, minus 1/8, get a common denominator, do the fraction. I don't really like fractions that much. I like to get rid of them. So I'm going to remind you how to get rid of fractions when you have more than one. Step 1, what's the common denominator for those fractions? Well, 8. If you said 8, you're right. Now, I'm going to multiply everything by 8, all 3 terms. There's 3 terms inside that bracket. Well, 8 times 3/4, that's going to be 6. And 8 times 1/8 is going to be 1. And 8 times v is going to be 8v. And my fraction is gone. Okay? So I've got minus 1, which gives me 5 equals 8v. And then I'm going to divide by 8, and v equals 5/8. That's your answer. Okay, here's the first part of video homework. Notice the directions have changed. Instead of solve, check, show all work, which is what you're very used to, it's solve, show work, check mentally or on paper. Okay, now keep going. There's another page of video homework. Here is the second part of video homework. Remember the instructions: solve, show, work, check mentally or on paper, whichever you need to do. Have a great night.